Okay, so last week we did touch on this, what an inscribed and a central angle is. So an inscribed angle is when you have, by the way, what is this called again? A to B? This is called a arc, right? Thank you for putting up your hand, Martin. So arc, and when it goes all the way across to any point on your circumference, those are called your inscribed angles. And wherever you make that inscribed angle, those are all the same. Okay. And then this one, when it goes to the center of the circle, that's called the central angle. So not center, but central. Okay, so keep that in mind. Remember on the test, I will ask you guys to label. I'm going to ask you guys the names of these terms. I won't ask what definition, but you need to know what I'm talking about. Okay, so let's do a little summary from summary slash like what they mean. Okay, so angles at the center is twice the angle at the circumference. So in this case, what is x? If your inscribed angle is 30, x is gone 60 because it is double. Right? So the central angle is double of the inscribed angle, so it's 60 degrees. What about this one? What is x? Catherine? 40. And what is that called? What is that angle called? Starts with an I. Inscribed, right? Because this is your inscribed angle. This is also your inscribed angle. It's bounded by this arc right here. Melody, don't get distracted. Okay, this is your arc right there. And you can see that both of these angles are my inscribed angles. Okay. This one, what is that angle? All right. Yep. Kaden? 90. Why?
Because it has a little box there that tells you the rating.
Okay, yeah, that little box right there is kind of a giveaway. But let's say I didn't draw that box, how would I still know it's 90? In a semicircle, what is this angle right here? What's that angle? In a semicircle, this is my diameter, so this is how many degrees? Yep, 180. So if my central angle is 180, this is my inscribed angle, which is half of it, so 90. Okay. Tangent. We talked about tangent last time. So your tangent, wherever it touches one point on your circumference, that line is called a tangent. And in fact, it actually forms an isosceles triangle with your diameter. Okay, so in this case, CB is also 6 centimeters. So if I connect C and A with the diameter, it actually forms an isosceles triangle. Okay. And number 5 right here, perpendicular line drawn, it's bisecting the chord. So bisect, again, we talked about this term on Friday. Bisect means cut in half. So if AD is 5, that means DB is also 5. What's my unit here? 5 what? Centimeters. Good. Okay, because we're talking about lengths right here. Okay. And then this is the big one that we talked about on Friday. We did a lot of this property, tangent radius property. So what is that angle that it makes? Tangent radius property. Ethan?
Basically, like any tangent line bisecting any radius bisecting like a tangent line is going to form a 90-degree angle.
Right. It doesn't even have to bisect. As long as it's a tangent and your radius, it will form a 90-degree angle. Yeah. Okay. And then this is an interesting one. Opposite angle in a quadrilateral inside a circle, they add up to 180. So opposite angles inside a circle, it adds up to 180. So in this case, that means x is 100 degrees. Okay. So some of you might think, oh, I thought it's the same, it's 80. It's not a parallelogram. So some of you might be thinking of parallelogram, but this is a property of a quadrilateral inside a circle. Okay. This one we don't really use much. It's just saying that if you have a triangle inside a circle, the exterior one is also the same as the opposite interior angle. So that's also 60. But we don't really use this one much, so you don't have to worry about it. Hey. Okay, so this is a nice little summary for you guys here. One thing I want to point out though is sometimes you'll see, like for example, like this, and then like this. Okay, let's say I have a triangle like this. Okay, A equals 40 degrees. Is that an angle or a length? Angle. So if it's an angle, it goes on the corner, and we're talking about the angle that two lines make. Okay, so that's angle 40 degrees. What about AB like this? When I write with two letters, that's a length. Okay, so then AB like this, I'm talking about a length of a line, then that's 4 centimeter. And I write that number in the middle. I've seen people write 40 like this. Okay, when it's an angle in the corner, not a length. So make sure you don't mix those two up. As simple as it seems, some people do mix it up. Okay, so remember, angle, length, don't mix them up. When I give you one letter, it's an angle. Two letters together, it's a length. Okay, so let's do these three examples. Let me see. Oh, I have very little today. Only 3 examples. Okay. So let's try this first one right here. Applying the inscribed angle, central angle idea. So O is the center of the circle. Determine the value of x. Okay, what is angle x right there? Who knows the answer? What is angle x? Let's see, Misha. Okay, half of angle y, but I don't know angle y. So let's we do have clues to help us find out what x is. Oh, okay, you found it. It's 55 degrees. Why? Yes. And so this is also your inscribed angle. The arc is bounded by AB right here. Okay, so if I know that ACB is 55, ADB is also 55. Then what is Y? Okay, as Misha already suggested, Ryan, 110. What do you call that angle? Not center angle. Martin, do you know? Central. Central. That's right. Okay, I'm not trying to be picky, but there's no such thing as center angle. Okay. It's like calling you your name wrong. Okay. Number 2. Applying the property of an angle inside a semicircle. Alright, so triangle ABCD has its vertices on the circle with radius 8.5. So the width of the rectangle is 10, what is the length of the circle? Right. So, okay, I'm looking at this. Well, it's a rectangle. What's a property of a rectangle? Yeah, Kaden? What makes a rectangle? Okay, what can you say about the angles in a rectangle? 90 degrees, right? So that's my little hint right there. I see a 90-degree angle right there. And based on what we've done for like the last week, we did a lot of Pythagorean theorem. Okay, so there you go. You have a right angle triangle right there. Since that's, let me just redraw this. Okay, I know that this is 10. Since 8.5 is my radius, that means my diameter is double that, which is 17. Okay, so I'm just doing Pythagorean theorem to figure out how long BC is. So BC, since I'm doing the side length, I'm doing the subtraction. So 17 squared, take away 10 squared. So the length of BC is, calculator, I can't do that in my head. So 17 times 17, take away 10 times 10. I get 189. Square root that, so second the square root button, 189. I get 13. What do I round this to? It says to the nearest 10. All right, based on your last test, some people still lost some marks with rounding. So round to the nearest tens. What is this? Melissa? Nearest tenth means one decimal place. So 13.7. Yeah. Okay, simply 13.7. I know that some of you are thinking, oh, but this rounds up and then this rounds up. When we want the nearest tens, we only look at the next digit. Okay, so 13.7 centimeter. Don't forget units. Some people forgot units as well. So even though like I sounded like a broken record and keep telling you to like units, yeah, units, Melody.
Oh, I was going to ask a question
about the rounding part on the test. Oh, yeah, on the test, I know I wrote round to one decimal place throughout, but then I was pretty lenient with it. As long as you rounded your final answer to one decimal place, I was fine.
Is that rounding rule where you only look at the next number of points?
Yeah, because normally, as I said in class, don't round in the middle until your final answer. But because some people were asking, oh, but Miss, 3.14, it's a rounded number already. So then I'm like, okay. So then I was like, 3.14 is two decimal place. And then if I ask you to round with one decimal place, it's like contradicting. And then I also say like, don't round in the middle. So then I was like, forget it. Just as long as you round the final answer to one decimal place, I took your answer. So whether you did your calculation using pi or whether you did your calculation using 3.14, I was pretty flex. Okay. And then this one, triangle ABC is inscribed in a circle. So AOB is 100. COB, this one is 140. So determine the value of X, Y, and Z. Okay, so the good thing is you are given the whole diagram. Okay, so your work is really cut down for you. Okay, who knows what is angle X? So in a circle, what's the angle in a circle? Come on, 360. So if I know that a circle makes 360 degrees, all right, part of it is 140, part of it is 100. So when I subtract it, what is angle X? Con? 120. That's it. Okay. So now here's the tricky question. What is y? What is angle y?
40 degrees.
40 degrees. Not quite. Alright, who knows the answer? This is the based on what we learned today. Oh, okay, Melissa, give it a try. Not quite. Too much. So more than 40, less than 70.
Well, it's a cube.
Adrina? Yeah? What is it? Did you say 60? 60 it is. It is 60. Why is it 60 though? Lucky guess. Well, very lucky guess. Okay. Kaden, do you know why? Alright. Eliana? No. Where's my big brains?
She's taking the test.
You have a big brain too. All of you guys do. Alright, so um, who knows why it's 60? Think about what we just learned in the beginning of the lesson today. What did we learn at the beginning of the lesson? Martin, do you know why it's 60?
The inscribed angle.
Inscribed angle. That's right. All right. Was that a lucky guess there, Martin?
No.
Okay, so AC right here, this is my arc. And can you see that the angle X right here? Here's my central angle. And angle B is actually my inscribed angle, bounded by the same arc. So if I found out that X is 120, then angle Y right here, which is half of it, is 60. Okay. Sometimes on the test or exam, what you could do is also rotate your whole diagram. So when you rotate it, do you see the arc better with your inscribed angle and central angle? Maybe. Yeah, try it.
Wait, is that like half? Not like half, like a proportion of 60? Because the inscribed angle it's that way, but there's also a line in the middle.
It doesn't matter because it's bounded by your arc. So arc AC, it goes to your center, and when it goes to your circumference, that whole angle is your inscribed angle. Yeah.
Inscribed is like the arc and then the point at the top.
It doesn't have to be top. It could be anywhere on the circumference. So if like let's say AC right here, I make an angle over here, what would that angle be? Here, I'll use a pencil. Like let's say this one right here from AC, what would that angle be?
Please excuse this interruption. With the following.
Okay, so what would that angle right there be? This is again the same arc. I'm drawing this is my inscribed angle. So this would be, Ethan?
Is it 60 degrees?
60 degrees.
That was
Yeah, got it? How do you know which arc to use? It could be any arc. So for example, right here, if I use arc AB, then that means if angle this, let's say I change up the question and I say arc AB is right here. This is my central angle. So what would angle A be? What would angle A be? So my central angle here is 140. So my angle A here would be half of it, which is 70. So your inscribed angle, you can be using any arc, and that property applies. Right. We'll do a couple more examples.
You know that line you drew earlier?
Yeah.
I didn't even know that there was 60.
Because that's my inscribed angle. So as long as it's bounded by the same arc, I know that the central angle is 120. So no matter where I draw, so I could draw it to here, that's 60. I could draw it to here, that's 60. I could draw another one to here, that's also 60. So all those angles right there are all 60 because I know the central angle is 120. Yeah. Okay. So Z. Okay, let's finish off this one and then we'll do a lot of practice on page 13 and 14. Z. Okay, so Z is tricky. Okay, who knows what angle Z is? Okay, Khan. More. Yeah.
30 degrees.
30 degrees. Why?
Because like line A to O and CO are like the radiuses of circle, right? So
right. This is actually an isosceles triangle because this is your radius, this is your radius. So triangle AOC is an isosceles triangle. Triangle AOC is an isosceles. Okay, that's how you spell isosceles. Okay, and so if I know that x is 120, so 180 minus 120 is 60, split it between these two angles, which are the same, you get 30. Okay, so the trick right here is recognizing that AO and CO are equal because they're the radius. Okay. Okay, so I'm gonna give you guys about 5 minutes to try page 13 and 14, and then we're gonna tick it up in 5 minutes. Let's tick these up. Number 1. Who has the answer for number 1? Adrina. How did you get 37? How did you get it? You forgot. Okay, it's very similar to how we did example 3. What can you say about line AO and BO? Yep, they're both radius, so it's that. All right, so let's recall your memory, Adrina. The angles in a triangle add up to 180. Yeah, so 180 take away 74. Whatever's left, you have to split it between these two angles. And you divide it by 2, you get 37. What's my unit? Degrees. That's right. Okay. Oh wait, it's not 37. 53, right? 53. 53. All right, because when you subtract it and then divide it by 2, it's 53. All right. Angle C. This one straightforward. What is angle C? Eliana. It is 90 degrees. Why? Inscribed angle. Good. All right, because this is your inscribed angle. Hey, C. Okay, remember one of the properties? What can you see? What happens to the opposite angles? Shoyam? Add up to 180, right? So x equals 180 minus 98. Shoyam, what did you get? 82 what? Degrees. And then y? 70 degrees. Perfect. All right, because opposite angles add up to 180. Hey, this one. So Ethan, I know you got this one. We're not assuming, but we know, as a matter of fact, that 3x minus 9 equals 90 degrees. All right, So when you move it over, you get 3x equals 99. So Ethan, what is x? 33 degrees. And so that means angle B is 34 degrees. And so since this is 90 degrees, 34 degrees, I can find out what y is. Y is 180 minus 90 minus 34. And Ethan, what'd you get? 56 degrees. Okay. Alright, so remember this is one of the properties because your diameter is 180, so your inscribed angle is 90. Right? And then, so this is like applying what we learned today. Okay, using the algebra to solve and then solving for the other angles. Okay, Melissa, what is angle X?
102 degrees.
Good, and why?
Because it's the central angle.
Central angle, perfect. Okay, Eliza, what is angle X in number 6? And it's called? Oh, not isosceles. The other I. Inscribed, right. Inscribed angle. Okay. Catherine, you are next. Number 7. Yeah. So same idea. So X is 32 degrees. And that's your inscribed angle. Okay. What about number 8? Now, number 8 is a little tricky. Kaden, what do you think? Number 8. It's not 23. It looks like 23. Let's see. Eliana, what did you get? Same thing? Okay. Martin, number 8.
So X goes to 23.
Okay, so if you paid attention, you would heard that that was not the correct answer. So let's pay attention. Shreya? It is 46. Why? Yeah, that's actually the central angle. It doesn't look like it, but it is. It's the central angle. Why? Because where's my arc? Right here. Okay, so you see this arc? They go to your circumference, which is 23. So that's my inscribed angle. When it goes to the center, that's my central angle. Okay, so that's actually 46. Okay, number 9. Okay, Khan, what is X? And number 9. 75, and your reason? Opposite, right? Oh, by the way, I forgot to mention one thing in the in Wednesday's lesson. I cannot apply the Z pattern right here. Okay, Z pattern, F pattern, C pattern. It's based on 2 specific lines. What do those 2 lines have to be? Melody? Parallel lines, right? Okay, so in this case, I don't know if these 2 are parallel lines. These 2 ticks right here means that they are equal in length, but it doesn't mean that they're parallel. Parallel is the arrows. Right? So don't mix those up. Hey, number 10 is tricky. Hey. Okay, so the answer is easy, but the reasoning is tricky. Okay, Catherine.
37?
Yes, it's 37, but do you know why though?
Because if you piece the 2 parts together, that's like the opposite thing.
Okay, so we're not piecing them together because we can't. Okay. the reasoning is.
The formula is, I actually don't know how to phrase it.
Okay. Good try.
Opposite?
Opposite? No. Opposite is when it's an X pattern. So this, I have the X pattern right here. But this one is tricky to see.
Two lines are equal.
Yes, those two lines are equal. So what does that imply?
Oh, if you flip it, it's the same.
Yes, right? Well, kind of. So this arc right here, this is my inscribed angle bounded by this arc. But if that length is the same as this length, then that means that arc is the same as this arc right here. And so that means this is also an inscribed angle. Alright, so that's the reasoning. This is an inscribed angle. Not because it looks like the same, not because you flip it or merge it, but because they are bounded by the same arc in length. Okay, so this arc will mean it's the same arc as this one. Okay, last two. So what is x? What does x equals here? Martin.
7. Wait.
7 what?
7 meters.
Meter. That's right. So all of these, we were talking about angle, so it's degrees. This one, I'm talking about the length of this line, so it's meter. I don't want to see you write 7 degrees. All right? Very different. And then now the last one, number 12. Little tricky. Misha, did you get this one? Let me do the math, and I will tell you if it's correct or not. What did you say? 34 it is. 34 degrees. How did you get 34 degrees? Right. So this angle right here is 52 because this is my inscribed angle. This is also my inscribed angle. So when you do 180 minus 52 minus 94, you get 34. Okay. Good job. So out of these 12 circles, how many of you got at least 9 of them correct? At least 10 of them correct. At least 11. All 12 correct. Okay, good job. If you got all 12 correct, awesome. If you did not get to 8 of them, okay, let's make class time more useful in the last 15 minutes. So homework, page 15 and 16. So more practice on inscribed angle and central angle. Inscribed angle, central angle is not hard, but it does take practice. The more you do, the more easily you can see the angles. So it's just more practice. So do these 2 pages, 15, 16, and then tomorrow we'll do the review on the next 2 pages.